All right, so this is our first video of the year, and there will be many, but this is number one. Now, these function notes are a little bit long, so I'm going to break this down into a few videos. I think I'm going to do 3, but we'll see how long that this one goes. But the first thing that we're going to talk about here is just basic functions. You've talked about some of this function stuff before, but it's always a good idea to review it at the beginning of every year. So a relation is very broad, very generic term. A relation is very simple. Anything that relates a value in set A to a value in set B. There's no rules there, there's no guidelines, it's just it relates a value in a set A to a value in set B. Everything you've done in math ever has been a relation, because like I said, it's very broad, there's no rules or anything like that. But functions get a little bit more specific. A function is a relation where each element in set A is assigned to exactly one element in set B. So now this is a little more specific. Put some rules in here. So we now have this relation, but every element in set A gets exactly one element in set B. Notice that it's not vice versa. One element in set B does not have to have exactly one in set A, but one in set A is assigned to one in set B. Now, we know set A and set B as different terms. Set A would be our domain. That's what you're more used to hearing. And remember, domain are our x values. Or sometimes you might hear this being called the independent variable. And then that would make set B our range, or our y values. And that would be the dependent variable. So no matter what x is, because x is independent, so you could pick any x to be anything you wanted, what would y then be? So you get one y value from that. And yes, I noticed that I write in all capital letters. That's just the way I write. Don't think that I'm like screaming at you or anything like that. That's just the way I've always written. Okay, so the next slide here has 3 different sets. Okay, and with ordered pairs, so x, y values for each one. So I just want to know, are these functions or not? Now before we even get to that, they're all relations. All of them are a relation, because again, relations have no rules. So everything is a relation. So beyond that, which ones are also functions? So some of these will be relations and functions, and some will be just relations. But nothing can ever be just a function, because it has to be a relation as well. Okay, so the first one, if I look at all of my x values, are they assigned to just one y value? And they are. So this would also be a function. For this next one, that's the same thing. Just because the y values are all the same, that's okay. Each x value, so 1, gets assigned one y value. Nowhere here does 1 get a different y value. So just because all the y values are the same, that doesn't matter. Remember, we said the function does not work vice versa. It just works that every x value gets exactly one y. So this would also be a function. Set C is the one that is not a function. If I look, all of these x values are the same. So 1 is getting assigned 4 different y values. It's being assigned 5 and 6 and 7 and 8, and we can't have that. So that's why this one is not a function. Now, function notation is just, instead of using a y, you would use f of x. And I know you've seen that before. You'll see in this class we use both of them interchangeably, y and f of x. We might use f of x a little bit more here when we're doing the algebra stuff, but once we get into trig, we kind of go back to the y. But you will see both notations, but they mean the same thing. So instead of having your point be xy, you could also see it being x f of x. It's the same thing, just a different notation. Okay? Now there's 2 ways to determine if a relation is a function or not. Graphically, you probably remember the vertical line test. Remember, that's where you pass a vertical line over a graph to see if it passes or not. If it only touches the function in one spot the whole way, then it's a function. If it touches the graph in 2 places when you pass the vertical line, then it's not a function. So we're actually going to skip ahead a few slides and find the one with all these graphs here. And we're going to determine if they're functions or relations. Now again, they're all relations. Everything is a relation. So relations have no rules. So everything is a relation. Now we just have to pick out which ones are functions. So if we were in class, I would have you do this on your own. So if you want to pause the video, take a few seconds, try to figure out which ones are functions, go ahead, and then you can restart the video and see if you were right. So our functions here, this would be a graph of an absolute value, that v, that is a function. Because if I would pass a vertical line along here, it's only going to touch the graph at one spot the whole time. This one is also a function. This would be a rational equation, like 1 over x. And again, there's an asymptote happening here. So even if I pass the vertical line, it's never going to touch the graph in 2 spots. This next one is a function, because right here is the only vertical line we have in question, but this is an open circle. So since it's an open circle, it's still only touching here at 1 spot. So it does pass the vertical line test. And that would be a piecewise function. You'd have 2 different functions happening there. This next one is a circle. This is not a function because the whole way across that vertical line would be touching at 2 spots. This one is a function. This would be the graph of a polynomial, something that had an even degree, like x to the 4th or x to the 6th. But again, the vertical line passes on everything. And then finally we have our parabola, but it's sideways. So this one is not a function. That vertical line would fail. And this graph would be something like y squared instead of x squared. That's why it's on its side. Okay, so again, that's the vertical line test to determine if something's a function or not. Now we're going to go back, and to algebraically determine if something is a function, we have to do just a little bit more work. So the first thing you want to do is plug in any x value in the domain. Now, what that means is I have to plug in an x value that's going to give me an answer. I can't plug in an x value that will give me something that's undefined, because if it's undefined, then it's not in the domain. So you have to plug in an x value that gives you an answer. Now, when you plug in that x value, one of 2 things is going to happen. If you get one answer, one y value, that means you have a function. it doesn't matter what that y value is. So if I plug in 6 and my answer is 4, it's a function. If I plug in 10 and my answer is 1 million, it's a function. As long as you're plugging in one number and you're getting one number back, that is a function. If you get 2 or more, and 99% of the time you're just going to get 2, but if you get 2 or more y values, then it's just a relation. Okay, so let's say you plug in 6 and your answers are 4 and 10. That is not a function. Let's say you plug in 10 and your answers are positive and negative 1. That is not a function. Okay, so plug in a number. If you get anything back, if you get one number back, it's a function. If you get 2 or more, it's not. Now, there is only one exception to this rule. If your y value is 0, you have to choose another x value and try again. Because 0 has some properties that maybe you should be getting 2 answers, but the 0 kind of negates all that. So if you plug in, let's say you plug in 4 and you get back 0, try plugging in 5 and get a different number. We don't want to get 0 as that answer. It's not a good test to see if it's a function or not. So on this page, again, they're all relations. Okay? And don't use up all this room here, because we're going to come back later and find the domain of the ones that are functions. So if it is a function, try to leave this blank so we can find the domain later. But for all of these, again, remember, they're all relations. Everything is a relation. But in these relations, which ones are functions? Okay? So again, try plugging in any x value into here. Plug in 1, see what you get back. If you get one number, it's a function. If you get 2 or more, it's a relation. So again, if we were in class, I would have you try these on your own. So why don't you pause the video, see if you can figure out which ones are functions and which ones are not, and then you can restart the video and see if you were right. Okay, so there's only 2 here that are not functions. This here is not a function. This would be a circle if you graphed it. But when you plug in a number, like let's say I'm going to plug in 1 for x. You get y squared is 8, and when you take the square root of both sides, I get y is positive or negative square root of 8. Remember, when you take the square root of both sides, you have to add in that positive or negative. So this one gives me 2 answers, so that's why it's not a function. And the other one that's not a function is this one right here. It's right here given to you, positive and negative. So if I plug in, again, if I plug in 1, you get positive or negative 2. So again, that's 2 answers. And if you were to graph this, it would look like an X. That's what it would look like. So it fails the vertical line test. Oops. Okay? All the other ones are functions. So if you plug in any x value, you should be getting only one number back. Now, some students have asked in previous years, why don't I have a plus or minus here when I had a plus or minus here? Well, that's because in my process of solving, I took the square root of both sides. Here, I did not take the square root of both sides. This square root was here already, and it's already positive. So I'm not going to add in a plus or minus because I didn't take the square root of both sides. So it's only when you do that process of taking the square root of both sides that you have to add in the plus or minus. Okay? The last thing we're going to do on this video is just the function notation. Just finding out what these values are. Now, anytime you have f of something in parentheses here, we want to plug that in for x. So this one would become 3 times 0 minus 2, which just gives me negative 2 as my answer. So again, for this one, letter B, it's just a number. So 3 times 2 minus 2. 6 minus 2 is 4. Now, even though these next ones have something different in them, there's a variable there, it's not just a number, it doesn't matter. You still go about this the same way. If I would give you f of smiley face, then you would put the smiley face in for x. Whatever is in this parentheses, we're going to plug in for x. So C here would become 3 times x minus 1 minus 2. And when I'm plugging in, I always put whatever I'm plugging in parentheses. That way I remember to distribute. So see, even here with a number, I put that in parentheses, just so I need to distribute if necessary. So this one will become 3x minus 3 minus 2. I can combine like terms to make it 3x minus 5. And finally, my last one is 5y, so I'm just going to plug that in for x, and that becomes 15y minus 2. Okay? So again, on the next slide, I would have you try these 4 on your own in class. So why don't you pause the video, give them a try, and then we'll see how you do. All right, so this one would be 7. This one would be 10. Letter C, I'm going to wait until last to do that one. So this one would become y squared minus 2y plus 7. And this one, sometimes we forget how to do the algebra on this one. And notice, because there are 2 x's in my original g of x equation, I'm plugging all of these in twice. So negative 3 gets plugged in twice, negative y gets plugged in twice, so x plus 1 gets plugged in twice. When you do this step here, remember that means to FOIL. This means x plus 1 times x plus 1. So I need to FOIL that. So this becomes x squared plus 2x plus 1. Then I distribute that 2. And now I can combine all my like terms. Okay, so now I'll combine my like terms. X squared plus 4x plus 10 is what you should get. Okay? Okay, so what happens if they don't give us the equation to plug into? Instead, they give us a graph. And I'm not sure, depending on who you had for Algebra 2 last year, if you went through this or not. But remember, we're just looking for points here. These are x values, and we're asking what's the y value. So if negative 5 is the x, we're going to go on our x-axis, find negative 5, 1, 2, 3, 4, 5 is right here. And then we're going to say, well, what's the y value on the graph? 1, 2, 3, 4. That's my point right there. So your answer is 4. If I'm going to do 0, let's see, 0, my x value of 0 right here. What's my y value? Well, that's this point right there. My y value is 2. For my x value of 5, 1, 2, 3, 4, 5, here I have an open circle there, and I have a closed dot here. Remember, the value lies with the closed dot. So my answer here would be negative 3. Oh no, I'm running out of colors. Let's see, purple. Okay. For 1, if my x value is 1, my y value is 2. And finally, let's do orange. Here, if my x value is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, my y value is 1. So again, this would be just like you were plugging into the equation if we had it. Plugging in an x value, your answer is your y value. Okay, so the next graph here, again, I would have you do this on your own, so why don't you pause the video, give it a shot, and then we'll see how you do. Okay, so here are most of the answers to this one. Again, remember that this is your x value, and they're just asking for the y value at that place. But I left this one blank because I wanted to talk about it a little bit. F of -6, that's right here. And I have an open circle. And there's no closed dots happening here. So that means there's no value there. But there is a correct answer. We're not going to use NA, we're not going to use no solutions, we're going to use undefined, because it is undefined. There is no value there. That value is undefined. So make sure you're not writing no solutions. No solutions is for an equation that you're solving and it has no solutions. This is just asking for a value, and that value is undefined. Okay, so that's going to be the first video. I'm going to stop there. So that is all on just the function, testing if something is a function, and function notation, and finding values. I'll finish the rest of the notes on domain and range and interval notation in the next video.